Dr. Gabriel,
Okay, I've
will
started.
do the first introductory slide. Momita, please share the slide.
Okay, sir. Just a minute. Is it visible, sir? Is it visible?
Yeah, it's okay. Okay, without further delay, today we have lucky to have with us Dr. Gabriel Ionut Plavan, Associate Professor, Alexandru Huza, University of Asi, UAIC, Department of Biology, Romania. We are really overwhelmed you accepted our invitation and agreed to give a lecture at this webinar despite of your busy schedule and weekend. We really thank you from our bottom of our heart. He is a world-renowned aquatic biologist, and his research area encompasses various aspects of aquatic ecology, ecotoxicology, and animal behavior. He has many awards and achievements to his credit. Few of them are: he is a member of professional associations like International Society of Limnology, Society of Limnology, Romanian Society of Ecology. He was recipient or a member of several national and international grants like MISTEC, Sources Pilot Center for Cross-Border Preservation of Aquatic Biodiversity and Fruit River, funded by Joint Operational Program Romania and Republic of Moldova, 2007 to 2013. He is a member of Natura 2000 and devoted to conserve aquatic biodiversity. He is an editorial board member of Journal of Survey in Fisheries Sciences and Limnological Review, the Journal of Polish Limnological Society. He has visited several countries in connection with his research work. Few of them are Canada, Italy, Germany, Poland, Turkey, Greece, Spain, Iceland, etc. He has published more than 50 research papers, 25 in highly reputed journals. He is serving as a reviewer for many international journals like Food Chemistry, Ecological Indicator, Environmental Science and Pollution Research, Human and Ecological Risk Assessment, an international journal, Atmosphere, Environmental Pollution, and Journal of Thermal Biology. With this background, I am requesting Dr. Plavan to deliver his talk titled The Influence of Intensive Aquaculture on Profoundal Organisms. Over to you, Dr. Plavan. Dr. Plavan, please unmute yourself. Dr. Plavan, please unmute yourself.
I'm trying to upload my presentation. I have a problem in uploading my presentation. How can I do it?
You open the PPT?
I want to upload my presentation. How can I do it?
No, you just go to the present now.
Yes, but I want to upload.
Then, no, from there you go to a window.
Which
present now? Present now. Right side. Present now.
Present now? Where is it?
Then a window.
Yes.
Then you just click your presentation.
Present now, yes?
Yeah, yeah.
One file.
You open the file first, the PPT file, then you
Present
do
now.
this.
One window. Yes, I can share. Yeah, just a little bit, please.
If it is not visible, the PowerPoint presentation, you just close it and again open it.
Now I have it. I'm sorry for this inconvenience. Hello to everybody. For today, we'll have a short presentation. I hope in 20 minutes, 25 minutes to do this presentation. We'll talk today a little bit about the influence of intensive aquaculture on profoundal organisms. Okay? Why this subject? We have because it's a very common subject for this year, for the last decade. Aquaculture is constantly increasing, and trout farms are usually built in upper reaches of rivers because these species require cold, well oxygenated, and of course unpolluted water. All the trout farms pose a constant threat to the water quality of highland streams, especially during low flow periods. The negative farms on streams is mainly caused by the release of fish food remains. We are talking about here the pellets. Yes, the food consists of uneaten pellets, and of course the fecal matter, which leads later to a deterioration of water quality, and of course changes of the bottom, the stream bottom or the lake bottom, depending on the position of this farm activity, modifying seriously the structure of the system. The relatively extensive research conducted in the past 3 decades on the influence of trout farms on recipient streams has focused primarily on changes in water physicochemical composition and of course the water basin structure. We are talking about here, of course, the bed of the basin. These investigations showed that such changes are primarily manifested as, so we will have some changes because of the aquaculture activity. First of these changes consists in the increase in concentration of both soluble and insoluble bond, soluble and insoluble phosphates along the phosphates and also the nitrates represents the base, the biogens, okay, the special substances which allowed the water blooming, okay, algal blooming, especially. The
Dr.
second,
Gabriel,
yes.
your sound is not very clear.
Sorry,
Your sound is not very clear.
my sound is not very clear. I'll try to do the best. Okay. My position is not so good here. The internet access, just a little bit.
And please, the presentation to be full screen.
Okay. We have only few words regarding this subject, and then I will present you the particular example. Yes.
Still it is not full screen. Still not full screen. The presentation.
Okay, I'll do the full screen. Just a little bit. Working now?
Yeah, now okay.
Everything is fine.
Your voice is not so very clear.
I cannot do anything about this situation.
Yeah,
There is
now
a problem.
now it's okay.
Now it's okay, yes? Everything is fine? Can you hear me now?
Yeah, now it is okay. Okay.
Okay, so I was talking about some changes caused by the activity of aquaculture, especially the aquaculture in floating cages. I'm concerning on the fish growing, salmon, through aquaculture in floating cages. So the main changes is happening in a river, or of course in a lake, like in my case, is increase in the concentration of both soluble and insoluble phosphates. Yes. The second one is the increase in nitrogen content, mostly in the form of ammonia and organically bound nitrogen, like nitrates and nitrates. The third one represents the decrease of dissolved oxygen. Yes, concentration. So think about the first two things represent a facilitation of algal blooming in a lentic ecosystem. Yes, the second one is connected directly with this algal blooming. It's decreasing the level of the oxygen in the water, which will lead finally to the high mortality in the hydrobionts. Yes, we are talking about the organisms in an aquatic ecosystem. Yes, and the fourth one represents the accumulation of suspended particles on the river bottom, river or lake bottom. We are talking about the bed of the ecosystem. Yeah. However, there have been reported many exceptions on what I was talking about on. Like, look, for example, no change in dissolved oxygen concentration was recorded in a trout farm somewhere in Portugal. Why this? Maybe because of the stream, maybe the velocity, water speed was very high. So the barbotation, if the water flow was very high, so there was no changes in, no decreasing the level of the oxygen. The other one, in Italy, the same thing was happen. In a river, no changes was happen in the level of oxygen. No increase in phosphates concentration was observed somewhere downstream from a trout farm, somewhere in United States of America, in Virginia. Oh, another example of exception, of course, these are exceptions, depending, of course, on the river basin, the physical-chemical condition in that river basin. So no increase in ammonia concentration. You know very well that ammonia represents a very harmful compound in the water basin. A very low quantity of ammonia is leading to a massive death of the fish, yes, inside this basin. So no increase in ammonia was in total suspended solids, dissolved solids in the water, was observed somewhere in Turkey. But correlated with this no changes, they observed a very high increasing in nitrates. Nitrates inside. Nitrates is a resultant of organic compounds decomposition. Yeah. So, like a conclusion, the effect of trout farms on macrozoobentic and of course on the ichthyofauna, on the fish, yes, of the recipient streams, have been less truly investigated. Generally, wastewater from trout farms causes decline. First one, causes decline of benthic macroinvertebrates diversity. Yes, the number of the species, the number of taxa is decreasing seriously. Yes, and of course there are some replacements of the more sensitive species by less sensitive ones. We are talking about here about apparition of new species, very cosmopolite species. So these are the species very common. You can meet these species, these cosmopolite species, anywhere in the world. So they are not still, we are not living here only sensitive species. The abundance is also modified. These cosmopolite species will be very abundant comparatively with the sensitive species. So in the beginning, we'll have a huge amount of species with a less number of the individuals. Yes, but then we'll have some changes in non-sensitive species, a very low number of non-sensitive species, but with a huge amount of individuals. The impact of fish farms is controlled by farm size. Yes, as long as the farm is higher, yes, the impact on the environmental is huge. We'll present a little bit later. I have a particular case somewhere in Bicaz Lake. Yes, on Izvorul Bicaz Dam Lake. You can see in this picture. It's a huge lake in Romania. It's the biggest lake with a position somewhere in the Carpathians. It's the biggest dam lake situated somewhere on an inside river. Yeah. So, in order to define the proper legal measure required to ensure full protection of sensitive truth streams, it is necessary to investigate the influence of as many types of truth farms as possible on the form of life in the recipient streams. Yeah? So, in order to assess the influence of the truth farms on the benthic macroinvertebrates, we choose for this goal this lake. We choose almost 13 sampling sites. The farming activity is concerned somewhere downstreams. The dam is somewhere here position. From the upstream to the downstreams, we choose 13 sampling sites. The intensive activity of fish farm in floating cage is situated somewhere in this gulf named Potoci Bay. Yes, in this area there are not less than 3 fish farms. Yes, 3 fish farms. Nowadays, this was a few years ago, but nowadays all this area, yes, is covered with fish farms. So the activity is huge. You can see some. I will not insist on the presentation of the sampling size. Just few images regarding the floating cages. Yeah, Sea Star cage is an invention. It's a new innovation by our university. Yes, all the cages are equally distanced, one by each other, and the production of the fish is huge in this direction. So we decided to have a witness sampling site, an undisturbed area, yes, with a normal condition, we'll see a little bit later, with a huge biodiversity. And of course, the rest of the sampling site, as far as all distance on the fish farming area, the conditions are better, yes, with a huge biodiversity. Yes, some images from the lake. This is the first sampling site. Yes, is the tail. We are calling the tail of the lake. It is extremely point, situated somewhere upstream of the lake, and we decided to investigate every stream area, every gulf, in order to establish the influence of every tributary. You can see the image of the dam. You can see the cars. The dam is huge. As I told you, it's the second dam lake in Romania, but the first dam lake in Romania situated on an inside river. And now you can see satellitary image, yes, with the farms in Potoci Bay. You can see the distance is not so big. The distance between the farms. Some images from my PhD period, when I was working to sample, yes, the benthic samples. Yes, by boat during the summer, during the winter. The condition was really hard, and I can feel now on my legs after almost 10 years what that it means, this work in the lake. And of course, we have done some investigation in situ. Yes, we use this device. It's a submersible underwater room we are calling bathyscaphe. It's a new invention of my university. So we can observe during the night and of course during the day how the larvae of chironomid larvae are emerging. As you can know, the chironomids, yes, there are some insects which are living as larvae on the bottom, inside the bottom of the lake, and during the maturity, we are living on the soil, in the air. Our instrument of collecting, a benthic dredge. Think about the deepest point on the lake is almost 100 meters close to the dam. Modernistic devices. A few years ago, we had the opportunity to buy a new boat, so now it's easier. All the samples were analyzed. Biological sample was analyzed in the faculty, taxonomically determined, and statistically interpreted. So now you'll have, of course, a little bit later, you can download all the presentations, so you'll have the taxonomical list. Because of the very short time disponible for this presentation, I will pass this this subject. We have a list, yes, a taxonomical list, with all the identified organisms in the lake. Yes, some humidity is the smallest shell met in the lake, just few millimeters. It's about Pisidium casertanum. Not a very common, but it's an indicator for water quality in the lake. Some snails, some of these species are new for this ecosystem. In the beginning, on this area, there was a river. This is a river, and after the construction of the barrage in 1960, there was a ecological succession from a river to a lake. So most of the species inside the river disappeared, and appeared new species common for the lake conditions. Chironomids, many chironomids species, crustaceans, isopods. So, doing a historical comparison of the species richness and Shannon diversity regarding the benthic macroinvertebrates in this lake, we can observe that after, before the 60s, yes, in the river there were almost 88 species of chironomids, but a total of 222 species, and in 2005 there remain only 23 species, only 23 species. 5 of them they are new for this ecosystem. Yeah. So what happened? It was a ecological succession, yes, from a river to a lake. So we can observe that in a river the biodiversity is higher compared with the biodiversity in a lake. Regarding the numerical densities, we can see, starting with the shore area, yes, the diversity is decreasing by increasing the depth, but the numerical density, so the number of the individuals, it's increasing by increasing the depth. We have almost 762 individuals in the shore area, and we'll have almost 11,000, yes, individuals on the profoundal area. The diversity, you see a Shannon diversity somewhere in the shore area of 1.7 and 0.3 in the depth area. So the balance between species is changing. Yes, in the shore area we have a big number of species compared with the profoundal area, where the number of the species is decreasing, but in this area it's increasing the number of the individuals. In this area we have only chironomids larvae and some oligochaetes, worms, yes, 3 or 4 species, yes, compared with many species in the, you can see here, the relative abundance, yes, the dominance actually of the macroinvertebrate species. We can see in the shore area, we have many species compared with the profoundal area, where we have only 1, 2, 3, 4 species. 4 species, but with a huge number of individuals. Yes, remember there are more than 11,000 individuals. A lot of, yes? So, we have here some graphs, yes? Some graphs regarding what we already discussed about them. We have done here some gravimetric analysis of the macrozoobenthos from environmentally because so the numerical and the gravimetrical densities can be observed here doing the comparison with the littoral and profoundal areas. So regarding the oligochaetes, yes, in the littoral area we have only 2,286 individuals, yes, weighing like 6.9 grams per meter square. So in the profoundal area, the number of the individuals is increasing. Yes, we have here 11,273 individuals with a weight of 8.4. So the weight is not increasing proportionally. Yes, the individuals are many, but with a less gravimetry. Yes, a less weight. Regarding the chironomys larvae, yes, also the individual numbers is decreasing, yes, from the littoral area to the profoundal area. Like also the weight is decreasing from 15 grams in the littoral area to 8.3 grams in profoundal area. Yes, we have here some graphs. Yes, you can see here the influence of we'll discuss a little bit regarding the influence of intensive aquaculture on the macrozoobenthos. We have here the first sampling site, the witness site, and the rest of these sites, yes, surrounding the farming area in floating cages. Some images from the farms, feeding the fish here. Yes, we have the fish here feeding. Some of these pellets are getting down to the bottom, yes, causing a lack of oxygen. And of course, enriching this area in organic substances. As you can see, the witness sampling site, yes, upstream the farms, the specific richness is higher compared with the rest of the sampling sites. Yes, the same is happening with the diversity. The diversity is higher in the witness area compared with the farming area. And as a conclusion, yes, we measure some chemical analysis, and we state that the content of organic substance, organic nitrogen and phosphorus in sediments in the aquaculture area, yeah, regarding to the other areas of the lake, the concentration of the main nutritive elements, yes, we can observe that the influence of the material emission from the fishing farms upon the chemical characteristics of the sediment is evident, as well as the differences of the chemical composition is not corresponding to the high quantities of organic and mineral material additionally introduced in the ecosystem through the aquaculture activity. You can see all these sampling sites, farming area, compared with the witness area. So despite of all economically advantages, the cage farm fish productions represent an environmental risk by the development of the organic waste emission, consisting mainly by uneaten food, pellets, and faces. Yes, the results from the fish farming activities. The analysis of bentofaunistical characteristics like composition, species composition, diversity, and abundance. Yes, we can state that they are sensitive approaches to evaluate the impacts on sediment and, of course, why not the surrounding environments. Just imagine with me diving inside the river. Now I'm in Constanța. In a few minutes, I'll start some divings. We have a project on the Black Sea. The Black Sea is somewhere behind me. I'm inside a hotel. Yes. In Costinești, you can write Costinești on the computer. You can see my position. Thank you very much for your attention, and I would like to invite you in Romania to go together to see our beauties. I am very sure that in Calcutta it's beautiful too, but maybe through the international programs, as Sumit now, I'm also the coordinator of International Relations Office to the Faculty of Biology of Iași. So I invite you all of you to come to Iași. I will facilitate you these exchanges, students. We have a new program, Erasmus, KA107, with partner countries. So we can become a partner country in order to do changes between our universities. Samit?
Yeah, Gabriel, nice for presentation. So, who are the participants? They must know that Gabriel is the Erasmus Mundus coordinator in Romania. So, who are interested in marine science or aquatic biology research for your future? So, you may contact Gabriel through his email ID. So, he's a national coordinator in Romania. So,
I'm sorry for the connection. Yeah, I'm running all the time. As you see, so yesterday I was in the mountain area. This mountain area I already presented you. Today I'm the Black Sea, 1,000 kilometers.
He's a very busy person and very terrific field worker. So I know him most of the days he's on the field. So you might have seen in the photographs. So he's diving, he's going somewhere and taking samples. So that's why he's super busy. But I'm glad that he agreed to spend some time on the weekends. Sundays are super busy for his family also. So anyway, glad Gabriel that you accepted my invitation readily whenever I told you. So thank you very much. And as I told all the
invitation
we'll go from
I tried to do this for you and to to come quickly. The traffic is so crowded during the weekend. It's still weekend. On Sunday we are in the weekend, so it was impossible. Last minute.
Due to the Sunday. So anyway, thank you very much. And now we'll hand over to Momita Ghosh, research scholar of Marine Ecology Laboratory. Some question and propose a vote of thanks to Gabriel.
My address, my Facebook address, and my email address is open to everyone, so everybody can write me. I'll answer certainly. Okay. I'll go back to my work.
There are some questions. There are some questions. You please take those questions before you do. I know you are busy, so you have to go to some places for sampling.
People are waiting for me.
I know you have Black Sea program sampling. You have. I know. You told me earlier.
Okay. Thank you very much for the invitation. Keep in touch. Bye to everyone.
Gabriel, some questions are there. Some questions are there.
Sorry?
Some question answer sessions is there.
So shall I
Can you hear me? Can you hear me?
Yes, now, yes.
Yeah, some question answer session is there. Few minutes.
Okay.
Over to you, Momita.
Thank you, sir. Thank you. Good afternoon, all, and thank you, Dr. Gabriel, for your stimulating talk.
Speak loudly, please. Speak loudly.
No, it's okay. I can hear her.
And it has been very motivating and relevant at this time when sustainable use of aquatic ecosystem is the need of the hour. And At the same time, aquaculture is also essential for our livelihood. So there should be a perfect balance between economy and ecosystem. So let's move on to take some questions from our audience. So the first question is asked by Orno Basu. He wanted to know, was there any effect on dam construction on the aquatic faunal diversity in your
Which is
study?
which was the question?
Was there any effect of dam construction on aquatic faunal diversity?
Of course, there is. All the time, the construction has an important role. It depending where the construction is done. It's very important. The materials important. The size of the aquatic ecosystem. There are many factors influencing this.
And he
I can
said,
give.
yeah, please continue.
I can give them some answers. Yes, please give Samit. Give them my email address, and I'll answer to everyone. Okay.
Okay. So I can understand you have to go somewhere. Okay, then
I can.
please take the question and hand over to Gabriel.
Shall I take last question?
Yes.
Okay, sir.
Please.
Thank you. Yeah. How can I work? This question is asked by Audra Chakraborty. She's asking, how can I work towards sustainable aquaculture? What is your opinion?
Okay.
Sir, can you hear me?
Yes, it's very the connection is not so
I'm
good.
repeating the question. I'm repeating. How can we work towards sustainable aquaculture?
What? Can you write me? Can you write me the question, please?
How could we work to the sustainable aquaculture?
The sustainable aquaculture.
Yes.
Sustainable aquaculture. Yes. Yes, we can discuss. It's depending through a very sustained research. It's very important to offer to the fish the quantity of the food. Yes, the quantity of the food necessary. We have to know the biology of every species. Yes, cultivated species. Also, it's very important where do you want to practice aquaculture. I never found ecologically a pure ecological aquaculture. Somewhere, anywhere in the world, we are combining aquaculture, fish aquaculture with aquaponics. Yes, growing of the plants inside the water. So this is the reason of aquaponics, in order to limitate the quantity of nitrogen, the phosphorus. I told you, it's depending on the size of the basin. If you are doing aquaculture in a small basin, in a small ecosystem, yes, it's better to combine aquaculture with aquaponic cultures, growing the plants in aquaponic systems. But if you are doing aquaculture in a big lake, like the Bicaz Lake, as you can see in other countries, there is no influence. So it's depending, of course, the size of the farm and the size of the. But sustainable aquaculture is very hard to discuss about it. Yes, wherever we'll meet aquaculture, there are some risks of disease. Yes, transferring the disease from the fish. Yes, culture fish to the wild fishes. Yes, and of course affecting the quality of the bottom. Yes, and of course the quality of the water. So it's better to let the Mother Nature to grow us, but it's quite difficult in this period. I have very good friends in Canada. They are practicing the aquaculture somewhere in the ocean. Yes, but even in the ocean, yes, it's a very large area. The influence is visible in this period. because of the food, uneaten pellets, and of course the huge amount of species. Yes, it's depending of course of the streams. If the stream is strong, all of these uneaten pellets and species are distributed to very wide, large wide area. Yeah.
Thank you, Dr. Gabriel, for your elaborative answers. And we apologize to the participants that we cannot take all the questions right now due to time constraint. So, but we'll surely deliver your questions with the permission to Dr. Gabriel. Dr. Gabriel, can we share your mail ID with the participants?
Yes, and of course Facebook ID, everything. I'm open to everyone. Yeah.
Okay, okay. Thank you so much.
I go back to work. Keep in touch with every one of you. Okay.
Yeah, sure. So, on the behalf of the organizers, we thank from the bottom of our hearts for accepting our invitation, sharing your time and experience with us from your very busy schedule. So, we are very much privileged and honored by your gracious presence in the webinar, and it's a great pleasure to hear from you. So, thank you so much again for being with us.
Thank you very much for the invitation. And keep in touch. Okay. Bye bye.
Thank you, Gabriel.
Bye bye.
Bye-bye. So that's all for the today's session. So we will join at validity sessions soon after finishing this session. So those who are interested can join that session also. We will send the link in Telegram group in 5 minutes. Thank you very much for your patience and understanding. Thank you.